Welcome to math classes. Today we'll see some problems in the integration. These are all PYQs from JEE 2025 or 2024. Okay, so this is the part 3 of the video. Other videos you can see my playlist and other integration shots. Okay, so let's get into the PYQs. Let a comma b be the point of intersection of curve x square equal to 2y and straight line y minus 2x minus 6 equal to 0 in the second quadrant. Okay, this is important. Okay. Then the integration from a to b of 9x square by 1 plus 5 to the power of x dx equal to how much? Okay. So why I said this is important is when you solve these two equations, you actually get 2 points. So you have to decide which one you have to take, right? So first thing is the intersection is very simple, right? If you solve the two equations, curve equation and the straight line, you get 2 points basically. So x square equal to 2y and y minus 2x minus 6 equal to 0. So which means x square minus 4x minus 12 equal to 0 or x minus 6 into x plus 2 equal to 0 if I factorize quadratic equation. If you solve x equal to 6 comma minus 2, and since x belongs to second quadrant, I should take only x equal to minus 2, which means y is 2. So my a comma b is nothing but minus 2 comma 2, right? So my integration now is integration from minus 2 to 2 of 9x square by 1 plus 5 to the power of x dx. Okay, so whenever you see integration definite integrals, you should remember one formula which is very powerful actually. Okay, so this is the one. Okay, very powerful formula and very useful for the definite integration solving. Okay, this states that integration from a to b of f of x dx is nothing but integration from a to b of f of a plus b minus x dx. Okay, and most of the times this will give you helps you when a plus b is 0 or a plus b is basically in a trigonometric function. It changes the it basically becomes a complementary trigonometric function. Okay, like pi by 2 you get a plus b as pi by 2 or something like that. Okay, very useful. Okay, always try to apply this one and see whether you get a result. Okay, now if I apply this one here, minus 2 plus 2 is 0, so 0 minus x. So in place of x I am replacing with minus x. So my integration will become integration from minus 2 to 2, 9x square, this is same, divided by 1 plus 5 to the power of minus x dx. Okay, so now if you see, numerator is same, denominator has changed. So if I add these two, 2i is nothing but integration from minus 2 to 9x square, 1 by 1 plus 5 to the power of x plus 1 by 1 plus 5 to the power of minus x dx. Now this one, if I write it as 1 by 5 to the power of x, correct? This will become 5 to the power of x by 1 plus 5 to the power of x, and this whole things, if I sum it, it will become 1. Okay, so now integration is very simple. It is just 9x square integration, which is 9x cube by 3, which is 3x cube. If I apply the limits, 2i is nothing but 48 and I is 24. That's the answer. Okay, next. Let f is defined as real to real function, be twice differentiable function such that f of 2 equal to 1. Okay, if capital F of x equal to x f of x for all x belongs to R, and integration from 0 to 2 of x capital F dash x dx equal to 6, and integration from 0 to 2 of x square capital F double dash x dx equal to 40, then what is the value of this one? Okay, capital F dash 2 plus integration from 0 to 2 of f of x dx. Okay, be careful, you have capital F and small f. Capital F normally represents integration of the f of x, small f of x. Okay, but you don't need to worry actually whether what is the capital F of x. You don't need to worry, because it is defined as capital F of x is nothing but x f of x. Okay, so you are given two equations, you need to get two variables, right? So you take first one. Okay, so first one is integration from 0 to 2 of x f dash x dx, which if I apply integration by product rule, okay, this will become x into integration from 0 to 2 of capital F dash x dx minus integration from 0 to 2 of capital F of x dx. Okay, so this is the integration by product rule. U v if I take, this is what it will be, right? F of x g of x. Okay, now observe carefully, this is the integration of differentiation of a function. So this results capital F of x, apply the limits, that's it, right? Okay, so this is nothing but x times, okay, capital F of x, and you apply the limits to capital F of x. Okay, and this is given as 6 already, right? This is given as 6, so I am taking 6 equal to this one minus integration from 0 to 2 of f of x dx. Now this one f of x is nothing but, okay, how you got capital F of x? F of x is given as x f of x, right? So if I apply limits to x f of x, Okay, xf of x, if I apply the limits, it will become 2f of 2, and f of 2 is given as 1. So this is 2. Correct? So this is 2 basically. Sorry, 2 times 2. Only the capital F of x limits, applying limits is 2 basically. So 6 is equal to 2 into 2, 4 minus integration of this one, right? So now the integration from 0 to 2 f of x dx is nothing but 4 minus 6. 4 minus 6, which is minus 2. Now this is your one part. This part you have already solved, which is minus 2. Now let's take the other equation. Okay, integration from 0 to 2 of x square f double dash x dx, which is 40, given as 40. Again apply the product rule. This will become x square into f dash x. Okay, because this f double dash, if I integrate, one dash will go f dash x, applying the limits, minus integration from 0 to 2 of 2x f dash x f dash x of dx, which is 40. Okay, now this part. Okay, carefully observe this part. This part is nothing but, okay, x square into f dash x 0 to 2. Correct? So if I apply 2, it will become 4 times f dash 2, and if I apply 0 limit, this will anyway become 0. So this is nothing but 4 times f dash 2 minus 2 times integration of 0 to 2 of x f dash x, which is already we know. This is given as 6. If you see here, right? This is already given as 6. So this is a 6. So 4 times f dash 2 minus 2 times 6, which is 40. So my f dash 2 is nothing but 13. Okay, carefully you do it, you will get 13. Now I have my second part also. Two parts are there. So my f dash 2 plus integration from 0 to 2 of f of x dx is nothing but 13 minus 2, which is 11. That's the answer. Okay, hope you understand this one, right? Next, if I equal to integration from 0 to pi by 2 of sine to the power of 3 by 2 x divided by sine to the power of 3 by 2 x plus cos to the power of 3 by 2 x dx, then what is integration from 0 to 2i of x sin x cos x divided by sine to the power of 4x plus cos to the power of 4x dx. Okay, so now you see this one. Okay, if I really apply this definite integration rule, a plus b minus x equal to a plus b minus x, I will actually get cos to the power of 3 by 2 x in the numerator, and denominator remains same. So which I can basically sum up and make it simplified, right? So this is one very powerful formula which we always use in definite integrals. Okay, and where you have trigonometric function as well as symmetry of this one, right? When you get complementary trigonometric functions, this is very, very useful. Okay, so informally in India, many people call this as King's formula. Truly, this is a King's formula for definite integrations. Okay, apply it very carefully. First, you check with this integration, definite integration problem. You check with this one first. Okay, so my integration is this one. If I apply this formula, it will also become integration from 0 to pi by 2 of cos to the power of 3 by 2 x divided by uh, cos will come here. Basically, here this will become cos to the power of 3 by 2x. This will become sin to the power of 3 by 2x, which is same basically, right? These two are same I. So if I add both of them, 2i equal to, okay, numerator, denominator you can cancel. So integration from 0 to pi by 2 of 1, which is nothing but pi by 2. So my I is, this is 2i. So I is pi by 4. Now I just need to solve the second integration, right? So second integration is integration from 0 to pi by 2, right? Because I is pi by 4, 2i is pi by 2, x sin x cos x divided by sin to the power of 4x plus cos to the power of 4x dx. Again you use this same formula. Okay, why? See this, what happens is, if I use same one, integration of pi by 2 minus x, sin x will become cos x will become sin x, so it remains same basically, divided by sin to the power of 4x will become cos to the power of 4x, this becomes sin to the power of 4x, again denominator remains same. Correct? If I add this f and this f, both if I add, okay, this minus x times sin x cos x will go off. Correct? So what I am left with is adding above to 2f equal to integration from 0 to pi by 2 of pi by 2 times sin x cos x divided by sin to the power of 4x plus cos to the power of 4x dx, which is, if I take pi by 2 out, this is what it is, sin x cos x divided by sin to the power of 4x plus cos to the power of 4x dx. Okay, now whenever you see such things, okay, you try to convert into tans. Okay, how you can tan and secant square you can convert. Okay, how I can do that? If I take cos to the power of 4x common, okay, from numerator and denominator, this will become Okay, f equal to pi by 4 because this is 2f. So f is pi by 4, integration from 0 to pi by 2. Okay, let's see first denominator. If I take cos to the power of 4x common, this will become tan to the power of 4x plus 1. And cos to the power of 4x, if I divide with the numerator, I'll get tan x into secant square x dx. Correct? Now it is very clear. If I take tan square x as t, tan x secant square x dx is dt, 2 times basically. Correct? So tan square x is t, 2 times tan x secant square x dx is dt, which means my numerator is nothing but dt by 2. Correct? So and the limits will change. Limits are basically 0 to pi by 2 will become 0 to infinity. Tan pi by 2 is infinity, so this will become 0 to infinity. Now my integration is nothing but pi by 8. Okay, pi by 8. Okay, because 2 is there, right? You will get dt by 2. Okay, so pi by 4 into 1 by 2, which is pi by 8, integration from 0 to infinity, dt by t square plus 1. Now this is, we know, this is tan inverse of t. You apply the limits. Tan inverse of infinity is pi by 2, tan inverse minus tan inverse of 0, which is 0, so pi by 2, right? This is pi by 8 times, sorry, I missed pi by 8 here, pi by 8 times pi by 8 times pi by 2, which is pi square by 16. This is the answer. Okay, next. Let f of x equal to 7 tan to the power of 8x plus 7 tan to the power of 6x minus 3 tan to the power of 4x minus 3 tan square x, and I1 is nothing but integration from 0 to pi by 4 of f of x dx, and I2 is integration from 0 to pi by 4 of x f of x dx. Then what is the value of 7I1 plus 12I2? Basically, we need to find this integration. Okay, you can substitute this f of x and try to solve the f of x, but it is better to simplify this one because it is involves all the tans, right? So make it into tan and secant square, then it's easy. Okay, so let's simplify first the given expression. So f of x is nothing but this is given. So I am taking from the first where 7 is there, 7 tan to the power of 6x as common, so tan square x plus 1. Okay, from here I am taking minus 3 tan square x, so tan square x plus 1 again. So this is nothing but secant square, we know. So this is nothing but tan square x plus 1 into 7 tan to the power of 6x minus 3 tan square x. Okay, or this is basically secant square x. Okay, this is my f of x, which is simple. Now if I take tan x as t, then secant square x is dt. This is nothing but 7t to the power of 6 minus 3 t square. So my integration is very simple. Okay, integration is nothing but 7t to the power of 6 integration is basically t to the power of 7x by 7 times. So 7 gets cancelled. You will be left with tan to the power of 7x minus, okay, tan cube x. Okay, if you really want one more step, you can take tan x as t, secant square x dx is dt. Then you will end up in this finally. Okay, so if I substitute limits here, basically pi by 4. So this is 1 minus 1, which is 0. Tan 0 is anyway 0. So I1 is 0. Okay, now I1 is 0, which we got. Now I2, let's go to I2. I2 is integration from 0 to pi by 4 of x times f of x. F of x is nothing but this value, right? So I wrote 7 tan to the power of 6x minus 3 tan square x into secant square x dx. Okay, so again I will write this as, if I apply product rule basically, okay, right, this is my I1 actually, right, x times I1 minus integration of 0 to pi by 4 differentiation of x is 1, so I1 dx. Now this one we already know, I1 integration is I1 is 0, basically I1 value is 0, correct? So this is 0 minus integration from 0 to pi by 4 of I1, which is nothing but, I1 is nothing but, if I remove the limits, basically it is nothing but tan to the power of 7x minus tan cube x, correct? So that is what I wrote it here. Okay, now this one just simplify it. You take tan cube x common, this will become tan to the power of 4x, sorry, missing, minus 1. This I can write it as tan square x minus 1 into tan square x plus 1. Okay, so instead of tan square x minus 1, this minus I am taking inside, it becomes minus 1 minus tan square x. Okay, tan cube x as is 1 minus tan square x into tan square x plus 1 is secant square x. Now if I take again tan x as t, this will become secant square x is dt. So this is very simple step basically. Okay, you can solve it yourself. I2 is nothing but tan to the power of 4x by 4 minus tan to the power of 6x by 6. If I apply the limits, basically I get 1 by 12. So I2 is 1 by 12. So my 7I1 plus 12 I2 is nothing but 0 plus 1, which is 1. That's the answer. Okay, next. Integration from 1 by 4 to 3 by 4 of cos of 2 cot inverse of square root of 1 minus x by 1 plus x dx is how much? Okay, so whenever you see this expression, we should get uh, cot of something. How can I get cot of something here? Okay, so by taking x as cos 2 theta. Okay, this is very important. If x is cos 2 theta, minus 2 sin 2 theta d theta is dx. Okay, so you should be very good in trigonometry also to solve this some of the integration problems. Okay, so now square root of 1 minus x by 1 plus x is nothing but square root of 1 minus cos 2 theta by 1 plus cos 2 theta, which is nothing but square root of 2 sin square theta by 2 cos square theta. This is nothing but tan theta. Correct? Tan theta, I can write it as cot of pi by 2 minus theta. So I am expressing this one as cot of pi by 2 minus theta, right? So cot inverse and cot gets cancelled. This is nothing but 2 times pi by 2 minus theta, which is pi minus 2 theta. So this whole expression is nothing but cos of integration of cos of pi minus 2 theta, correct? And dx is nothing but minus 2 sin 2 theta d theta, that I wrote it here, and minus sign I kept here. And cos of pi minus 2 theta is nothing but minus cos 2 theta, so minus minus gets cancelled, and this is nothing but integration from a to b. A to b I just kept because I don't want to change this limits. I will convert it back to x, terms of x. Cos 2 theta, 2 sin theta, this is cos 4 theta, correct? And sorry, sin 4 theta. Okay, so integration of sin 4 theta d theta is nothing but minus 1 by 4 cos 4 theta. Now cos 4 theta I will express it as, okay, 2 cos square 2 theta minus 1. Okay, now cos 2 theta is basically x, so this is 2x square minus 1. Now apply the original limits. Okay, because everything is in terms of x, apply the original limits. Okay, which means carefully apply minus 1 by 4 as is. 3 by 4, if I take x as 3 by 4, this 3 by 16, okay, into 2 is there, so 3 by, sorry, 9 by 8, 9 by 16 into 2, which is 9 by 8, minus 1 is as is, and 1 by 4, if I apply, this will become 1 by 8, minus 1 by 8 plus 1. This is, if I simplify, minus 1 by 4, this is the answer, okay. Be careful while applying limits, okay. Now the same problem, you will solve it more easily. See, here you have to remember, you have to take x as cos 2 theta. Correct? Not remember by looking at this expression. If you are good in trigonometry, you can tell that. Okay. Let's say we'll solve it in second method. More simple. I will take this whole expression as cot inverse of. Okay. Theta I am taking as cot inverse of this one. This cot inverse of this one I am taking as theta. So this expression will become cos 2 theta. Okay. Now what is it? Cot square theta is 1 minus x by 1 plus x. Okay. But only thing you should remember, cos 2 theta is cot square theta minus 1 by cot square theta plus 1, which means, okay, which means this whole expression, if I substitute here, cos 2 theta is nothing but minus 1 by x by 1 plus x minus 1 divided by, 1 minus x by 1 plus x minus 1 divided by 1 minus x by 1 plus x plus 1. If you simplify, you'll get minus 1 for cos 2 theta. And this whole thing is cos 2 theta actually. Correct? So cos 2 theta is nothing but minus x. So integration is nothing but integration from 1 by 4 to 3 by 4 of minus x dx. Everything is in terms of x. Very simple. So this is nothing but minus x square by 2. You apply the limits, you will get the answer. Okay, 1 by 2, if I take common, this is minus 9 by 16 plus 1 by 16. This is minus 1 by 4. Same answer. Okay, this is more simple. Here also you should remember one step. But if you don't remember also, you can express this. Basically, you can express this in terms of cos 2 theta because you are going to get cos 2 theta. Cos 2 theta I will express in terms of cot square, right? This is the step which you should remember. Okay, you can decide which one is easy. You can follow that. So this is the answer. Okay. Yeah. So that's all. These are the 5 questions basically. I want to just explain here. And there are more problems in my playlist. You can look at my integration playlist. Same this playlist link I'll give it in the comments. Thank you.